Let's talk high level very quickly about the different colors of the nodes and what they mean for you so that when you're looking at different materials or the materials you're building, we can get a better understanding of what's happening. So, one thing I want you to understand is that the color of the node does matter, and it can be useful for us as we move forward. So, for example, wherever we see a red node, for the best part, this denotes an input. And even if you look really closely, which sometimes can be hard, it does say input data. So this is some kind of information that's being kind of inserted into our material that we can then work off of. For example, whenever the game is running, this time value is constantly increasing. And we could use that to do something like, say, in these hard-coded nodes, the time value, we can imply that we could connect those together, and then we would get that time as an input. We can do other things that we won't go into the specifics of, but grabbing positions of objects, checking the color of the vertices, or where is this object in the world space. So again, red nodes kind of denote data coming into your materials. The next kind of thing you'll see is this kind of darker, kind of mute green color. And what these are hard-coded math and operations that the materials can do. If I take this node and I double click on it or do anything with it, it is what it is. There has been code written that is not functional, we can't change, and these are just built into the engine. Now, the next version is that Unreal has provided us some additional math and operations, but you'll notice a blue kind of top to them. We might be asking ourselves, well, what's the difference? I thought, everything that's in Unreal, it would be this solid green color. Well, any one of these that you see has got a blue kind of title to it is actually a kind of a built-in material function that Unreal has built with the default hard-coded nodes. So if I come and I take, let's say, this hue shift node and I open it up, you'll see that it's actually created with inputs, the red nodes, and green nodes, the kind of hard-coded math nodes that come in Unreal. And this can be really great on your exploration of learning materials because we can dive in and understand better what nodes are they doing and how do they work. If I come back up to the top here and close out of this specific node, I can go back and I can see this. So again, if you're ever curious and you have a blue node for something that Unreal has built in, we can just kind of check it out, which can be really handy. The next thing to understand is if you see kind of a lighter green or a more saturated green, this just stands for a singular value, a constant. So a value of 1, of 10, of negative 80. So it's just a single one. Anytime we're adding it more kind of dimensionality, so a constant to a vector, basically we see this yellowish color. That just denotes again that this is probably a vector of some type. And the last kind of thing we can look at is parameters. So we don't need to go too much into this, but it allows us to convert some of these hard fixed values into something that can change while we're running the material. And again, some of them have this kind of off green blue color. And you'll notice here that when I take say a vector 4 or a vector 3 and I turn it into a parameter, it still keeps its same color. So we kind of can understand, oh, I'm dealing with a vector. And if it's this green color, oh, I'm dealing with a constant. So again, make that correlation there. So again, at a high level, I want you to understand that reds are kind of these inputs, greens are hard-coded nodes, blue nodes you can open up and kind of digest and understand what's happening. And then we have some other math nodes that are more high level that allow us to very quickly see what kind of data we're working with. So hopefully this is helpful, and I'll see you guys in the next one. Let's make a material that goes over a very core concept that I think will be important for you going forward. So again, let's go into our content drawer. And if you haven't already, inside of here, we're going to make a folder. I have one called material examples. Feel free to place this where you want. And I'm going to right click and make a new material. And I'm going to name this material M_RGB01. And something I want you guys to start to realize is that the colors in Unreal are associated with directions. So if you notice in the preview sphere here, we have X going in one direction, Y in another, and Z going up. And why is that important for us in materials? Well, you'll notice that the X, Y, and Z coordinate here is actually colorized. So let's show you what that might mean for us. if I come into the scene and type in constant 3 vector, you'll notice we have, again, red, green, and blue. And why is that useful for us? Well, because in the future, we can use such nodes to affect position, look at where something is in space. And this is something that is just a core concept that is important to realize early on, is that we have control over possibly where the object even is in space. So as a quick aside, if we think about the X direction being tied to red, right? If I take this, and again, the white pin is all 3 of them, so 3 numbers are coming out, and I plug that into world position offset, nothing happens. But if I come in here and type 50 into R, what just happened? Well, the sphere has a visual glitch because of nanite, but we won't talk about that right now. And then we'll go to 150. You're noticing the object is actually shifting across the viewport here, away from its original origin. And that is because, without getting the specifics of world position offset, we are converting RGB into XYZ, because that is what's being fed into here, and it's manipulating the vertices. So I just wanted to give a high-level video that kind of talks about the concept that we want to start thinking about RGB as XYZ, because this will start affecting things like coordinate spaces and other things in future videos. So hopefully that makes sense, and I'll see you guys in the next one. Let's talk about a concept that we kind of already covered a little bit, but if not, let's just talk about the details. So in the content drawer, again, I'm going to have a materials example folder. Feel free to save this wherever you want. I'm going to right click, make a new material, m_texture sampler 01. I'm going to open this up, and if you've been following along, you should have made a example file with us, but if not, if in here we have some textures and I have base paint, brick wall, red paint. If I come in and I open a texture and I left click and I drag it into my viewport, or if I right click and type in texture sample, you'll notice that I have 2 of these different texture samplers. And the texture sampler itself is actually not the texture. I know that might be a little confusing, especially if I left click, drag this into base color, you'll notice a texture appears. The interesting part is when we click on the texture sample, down here we actually have a texture object. And this gets a little confusing, but we can think of the texture sampler as the thing that processes textures. So we don't inherently, if we have a JPEG, we can't just show that. We need something to interpret it. And that's actually what a texture sample does. And we can see this through a different concept because there is a texture input here. So if we type in texture object, and you'll notice because I already have the texture selected in the project down here, it's auto defaulting to it, but we could set this to none, or we could clear it, okay? And if I put this into texture, you'll notice, first of all, I get an error. It says, hey, you require a texture. And a texture object is basically the actual raw texture data. So again, if I type in brick wall and I attach this, what you'll notice is that when I click on my texture sampler, this texture sampler now is feeding a texture, interpreting it, and then putting it out to the base color. So when you're working with texture samplers in the future, realize that this is kind of like a small processor, and that by default, Unreal gives you the luxury of having down here in your texture section, and I could change this to anything I want. So let's just change this. And if I plug this in, I'm now using this texture sampler. Now, one kind of high level note about texture samples or texture samplers is that there is a fixed number of them that we can use. As you can see, texture samplers 5 of 16 in this configuration. So you don't have an infinite number of these to use. So if you ever start running into problems because you have too many texture samplers, notice that that might be it. And that is a restriction based on how the shaders are compiled. So when the material gets built after we're all done here, that's why. So hopefully now you know a bit more about texture samples and texture samplers and their usage inside of Unreal. Let's cover another core concept, which is called texture coordinates. So let's open up the content drawer and we're going to make another material here. I'm going to name it m underscore texture chord 01. And let's open this up. And from here, let's talk about what texture coordinates are and how they affect our meshes. So what I'm going to do is I'm going to actually minimize this, or you can just come down here to the content drawer. And let's go to our textures folder and we're going to go to our brick wall. And we're going to take this brick wall texture, left click and drag it in. And the very first thing you'll notice is after we left click and connect it to our base color is that this object is tiling around our sphere perfectly in 0 to 1 space based on its UVs. So if we go to the cube here, you'll see that this edge is right here and this edge is right here. Now, how does it know what that is? How does it know to map that object perfectly to that? Well, if it's not defined, we have this UV space. So if I come in here and type in texture coordinate, this texture coordinate is exactly what is already by default being assigned to this UV0. And if I just plug this in, nothing happens. I can apply, and you're like, okay. So what we have set up here is exactly what was happening before they were connected. So you might be asking, well, why is this important to us? Well, first of all, we can see with the text chord unit here, if we click on it, we actually have access to U tiling and V tiling. And we want to think about U and V, and this is a little interesting, but if we align our viewport where X is going across and Y is going down, will be aligned with the texture coordinate system. And if I set this to, let's say 4 in the U, you'll notice now U is assigned to the X, it's like a crossed, and V is to the Y-axis, it's kind of like the vertical. So I like to think of it as V as vertical, even though it's kind of descending. So we can set that to 4, we could set the V to 4, and you'll see now our object is tiling 4 times. So 1, 2, 3, 4. 4 across this way, 4 down that way, 16 extra times. So what we can look at now is, let's say we set this back to 1, and we set this back to 1. If I don't have a texture sampler in here, which again, this is a great way to start tiling or actually shrinking, the other thing we could think about is taking these values and halving them. So what do you think will happen? If this is 0 and this is 1 in texture space, if I halved it, you'll notice it's now only getting to the halfway point of that texture, which again is a very powerful way for us to manipulate our textures to do the things we want to do. If I just plug this text chord into base color, I set both back to white, you'll notice we have this funny looking color. And what it is, again, if we think about X is red, Y is green, in this upper corner, we're starting at 0. And as we go across, we're going all the way up to 1 in the red channel. And as we go down, we're going all the way to green in the V channel. And what we could do is we can see that this is our UV space. Now, if I type in 4 and 4, you're not going to notice much because these values are going above 1. So Unreal can't show something brighter than 1. But we can see now this has gotten a lot smaller. So again, if I come back to 1 and 1, that gradient has tightened up. So again, that's kind of what's happening is we're not just going from 1 now. By the end of this, we're going to 4. And because we can't preview numbers higher than 1, it just is kind of tightening that gradient up. So hopefully you have a better understanding high level of the texture chord node. This is used to manipulate our UVs so we can adjust tiling, things like that. Let's talk a little bit about vectors and constants. So we're going to make another material to showcase this, and I'm just using a material examples folder here, but I'm going to right click, make a material. I'm going to name it m underscore vectors 01. And I'm going to double click this to open it. And if you've been following along, you might have already used one of these. If not, we'll just explain it. So if I right click and type in constant, you're going to see I have both constant, constant 2, 3, 4. And these ones say constant 2 vector, constant 3 vector, and constant. So let's just add a constant. And then right click, and then we'll type in constant again, and let's add a 2. And then constant again, and then let's add the 3 vector. And I guess why not? Let's just add the last one too. Constant 4 vector. And let's talk about what these are useful for and how to think about them. Well, sometimes, if you've been following along, we need a value that just goes from 0 to 1. So if I plug in this scalar, so again, a single value that can go from 0. If it goes to 1, it's white. If I'm at 0.5, it's half. 0.25, I'm getting grayer. 0.1, you'll notice that. 0.01, nearly black. 0 is black. So a scalar value is very, very valuable when we just need to modify something by, let's say, multiplying it. We want to just kind of move all the values up. Where a 2 vector can come in handy is the x and y components. So we might be asking ourselves, well, why would we want to use something like this in a material? Well, if you've been following along, we have the ability to manipulate, say, texture coordinates. So if we're going to do texture, let's do a texture sample. So again, right click to create that. And I'm going to come down after clicking on the texture sample. I'm going to come down here to this texture, click, and type in brick, put the brick texture on it. And then we're going to plug that into base color. And then I'm going to add a texture coordinate node. And again, if you've been following along, you might know what this is already, but this is basically a way for us to adjust the UVs. And if I plug this in, you'll notice nothing happens. It's the same old, same old. But we got to think about what's coming out of texture coordinate. What's coming out of texture coordinate is a U component and a V component. So this wire is sending actually 2 different values. It's sending an X and a Y, a U and a V. Same things, X to U, Y to V. And we can think X to U, Y to V. And so if we make a multiply by holding down the M key or right-clicking and typing multiply, what we're going to do is we're going to take out the values inside of this text coordinate, and we're going to multiply it by this X and this Y. So if I just add this in, you'll notice no problem. I am multiplying by 0, so it's taking the first pixel and stretching it across. So where did our texture go? And that's Y. But if I set this back to 1, you'll notice it's taking the utmost pixels and stretching them. And if I go to 1, you can see I'm basically scaling this text coordinate, which has 2 components, by something with 2 components. And again, the order will always be XYZ, and the order will always be RGB, and they are correlated. So hopefully this starts to make some sense / give you some ideas about if we, times this by 4. So now we have 4 times the other value coming out of here. Again, 2 numbers are coming in over this line, 2 numbers are coming in over this line. Multiplying them together, out comes 4 and 1. So the U is 4, out comes 1. Now, moving on from that a little bit, let's talk about a constant 3 vector. So again, why is it 3? It has 3 components, RGB, X, Y, Z. If we start thinking about that, what we can do is we can do things like color manipulation, because most of our monitors are in RGB. So again, if I take this white pin and pull it out, we can think about 3 values are being sent over this. The RGB values are being sent over RGB, and we get a color. If we double click on this and we set the color by pulling these sliders up by left clicking in them to red, you'll notice now I can generate color inside of the material editor. And this is super handy for us because we don't have to use a texture sampler. And if you've been following along, texture samplers have a cost that's rather high and you can run out. So at times we can just generate solid colors or use them for other kind of things inside of our materials. This can be really handy. So we could also just output just one of the components, right, from the vector. And what is that? White. Well, why is it white? Because if we're looking at X, Y, Z, RGB are the same. So X is R, green is Y, blue is Z. what value is coming out of the red channel? Just 1 right now. So if I set this to 0, it is changed to 0. There's a visual glitch. But if we look down here, it's set to 0. Oh, set to 0. We're going to get black. And if I come back up here and plug this in, set this back to 1, or set this value, I can get different results. So this allows us to access 3 values at a time. Now, here's the interesting part. Remember, we talked about the values coming out of the pin as being 3 values, and the values coming out of this is 2. If you see, if I hover over it, I can see how many outputs are coming out with that little comma. If I try to plug this in here and apply it, you'll notice the Z component is just ignored. It doesn't know what to do with the Z component. If I set X and Y to 1, it's not going to know what to do with this Z component when multiplying. So if I plug this in, you'll notice I get an error. Why do I have an error here? Well, I have 2 things coming out of here, an X and a Y, but I have 3 things coming out of here. And Unreal is trying to make sure that you don't make mistakes. And you can see why is that? Because a float 2, this has 2 values, and a float 3 coming out of here are not compatible because Unreal knows that information is being lost and they want you to be aware of it. Okay? So again, if I know how many units are coming out and how many units are coming out, I can just multiply them together and get around that. Now, finally, as a real quick aside, if we think about RGB, then a 4 vector is just RGB and alpha. So what do we mean by alpha? Well, we mean the ability to use the first 3 channels to set a color. So again, let's set it to red. And then if we temporarily change our object, our material here, to use a different shading model. So if I just left click in open space, not on a node, just in the middle of nowhere, and I come down here and I set the shading model or the blend mode. Let's set the blend mode to translucent. You'll notice that it is solid and opaque. But if I take the alpha out, the 4th value of this vector, plug it into opacity, I can drive how visible it is by that value. So the R, G, and B take care of the color. And then if I set the alpha back to 1, it comes back. If I set the alpha to 0.5, it's translucent now because the white to black value, 0 being invisible, 1 being opaque, allows us to have a single node to control not only the opacity, but also the color. So hopefully this makes some sense as a high level overview of what these constants are. So constant 1, 2, 3, 4 vectors do, and how we can start to use them and start to think about them inside of Unreal. Another really helpful thing we can do is look at the math nodes inside of material editors. So again, we're going to make another material here, come into your content drawer and save where you need to. And I'm just going to happen to save mine in this core nodes folder I created, but we're going to go to materials. I'm going to name this m_math nodes 01. And what we're going to look at is a couple different nodes. First of all, we can type in add. We can type in subtract. We can do divide and multiply. And sometimes you type it out a little bit more specific. Okay, there you go. And so with these, we can do quite a bit. And you might be asking me, well, why would I want to use these? And the answer is sometimes we'll have nodes that are specific to, let's say, grayscale or black to white. And it can be really handy to add a color to on top of something or subtract it from it, or to multiply color. So again, let's just make a constant 3 vector and assign it a color. And if I just assign this, let's actually just make it kind of a gray color without any color on top of it. And if you notice, if I take this pin and I left click, drag it into multiply, and I drag this out to base color, the very first thing that happens is nothing special happens because we're multiplying this value, this X, Y, Z. All 3 of these values get multiplied by 1. So the X value gets multiplied by 1, Y, Z, etc. Now, let's say that I just wanted to darken this texture. Well, if I multiply by 0.5, what you'll notice is my texture now darkened. And what you might be asking yourself is like, well, what is that actually doing? Well, we're basically halving these values by multiplying by that. And I can put this to 0.25. And the same goes for divide. If I divide by 1 and I plug into base color, we get our base color. But again, if I divide by 2, I get the same thing as if I multiply by 0.5. And you might be saying, well, why is that? And it's because they're reciprocals of each other. But usually if you have the option of using multiply or divide, the multiply node usually is a little cheaper in terms of the math calculation. So I usually prefer to just use multiplies with fractions or a decimal value. And so this is something we can think about. The other thing we can do is not just multiply it by a single number. We can also come in here and I'm going to hold down the 3 key on the keyboard and left click to do the shortcut to create a constant 3 vector. And I'm going to plug this into multiply. And again, we have this to our base color. And you'll notice it's multiplying all these values by 0. So anything by 0 is 0, so it's just black. But if I come in here, and remember our original color is just white, I can actually come in here and make it say red. And what I'm basically doing is tinting my color by multiplying all of its values by this red value. And this allows me a lot of freedom to be able to kind of customize the color of something. So let's say I made a chair or a table. I can just come in and change that color very quickly. And again, the same is true for if we were to add or subtract from each other. So one thing I can do is type in, let's say linear gradient. Yeah, linear gradient. And what this is actually going to do is create a gradient just like you would maybe see in Photoshop. So I can pull this node off to add, and we could start previewing this node. And what you'll notice is that this is a gradient that's going across. Let's actually do the V coordinate. And right now I'm adding 1. So I don't want to do that. Let's just add 0. So this is what that texture looks like, or that UV. And so I get this gradient kind of going like this. And again, if I just add to every value, if this is 0 and it gradients up to 1, if I add 1, we're now actually at this value, now it's 2, and now that original value that was 0 is now 1. And so we can like brighten things up. We can take the ability for us to kind of get rid of like color information. We can also do that in the opposite direction. We can actually darken our material, but we would have to use the subtract. So we'll come in here, we'll do 0.8. And now I'm subtracting 0.8. I'm just still previewing this, so we got to preview this one. And you can see here I can actually remove color information. And what this is helpful for is as we get into other tutorials, we'll talk about how to use these grayscale maps to be able to control information about where things are happening. And again, this is just like a high level approach to some of the math nodes. The last math node we can talk about is the POW node. So I'm just going to type in POW for power. And this will just raise any value to a power. And so it times itself. So here, if I take this V gradient, type it in base, and go to base color, hit 1, and then I'm going to right click, start previewing node. You can see that this is the gradient we started with. And if I type in 2, I type in 3, 4, what we're doing is we're multiplying out, or powering, taking to the power of that. So this can help us control where the gradient is. As you can see the example when we were subtracting, our gradient was staying tight, and this is kind of changing that out. We can actually also do a decimal, which would be on the exponent here, and this will tighten up. So a lot of times you can use the power node to kind of tighten up masks or clamp data. So hopefully this gives you an overview of some of the math nodes that we're going to be using and how these can be useful for us in the future. Sometimes when we are doing different operations, we want to make sure that we clamp or make sure that our data ends up in a 0 to 1 range. So let's take a look at clamping real quick. So in the content drawers, I just have a folder here called core nodes, and I'm just going to make a material by right clicking, going to materials. And I'm going to do m_clamp_01. And I'm going to open this up, and we're going to talk about what's actually happening. So if I hold down the 3 key and left click to create a constant 3 vector, I'm going to connect this into emissive. And you're going to notice at first nothing's going to really happen. And if I come in here and I set this all the way up to pure white, so 1 in the R, G, and B, and we look at it, it will have a certain quality to it. But you're really noticing it's not kind of, it's only just basically pure white. But if you notice, if I come in here, and actually I set each one of these to 40. What you'll notice now is that this seems to kind of be glowing. It darkened the background. It's now brighter than it was, and it's simulating the idea of kind of like emission, like it's putting out more energy than it was before by kind of darkening everything else around it. And sometimes this is not the effect we want. Sometimes we'll do a math operation or something else, and we'll be in a situation where the value coming out won't be in that 0 to 1 range. So there's two different things we can do. We can either use a clamp node, which is a node that if we plug this into, and we plug it into emission, you'll notice it goes right back to what it was before, where these values, even though they're 40, this is saying whatever the minimum value is now going to be 0, and we want whatever the highest number, so 40, clamp it down to only go as high as 1. And this can be really helpful when we're working with black-white masks and things like that in the future. Something else to be aware of is that there is a node called saturate. And saturate, if we look at the tooltip, if we hover over it, it clamps the value between 0 and 1. And it says this is mostly free on Modern Graphicsware. So in most cases that you need to clamp between 0 and 1 and not between, let's say, -1 and 1, or let's say 10 for some reason, we would use the clamp node. But in any other case where we just need it between 0 and 1, we should always use the saturate node. And this can be really helpful for us because it allows us a really cheap version of clamp when we know that we're going to want to be between 0 and 1. Let's look at a concept called appending inside of Unreal Engine. So again, in my content drawer, we're just going to make a material wherever you see fit. I'm in my materials examples. I'm going to right click, go to materials, and then m_append 01. So I'm going to open this up, and we're going to take a look at what the append node does. So if I right click and type in append, you can see I can append many, I can append vector, append vec4, append vec3. Let's just do append vector. So we might ask ourselves, what is this and why would we want to use it? Well, sometimes we'll have, let's say, a scalar or a constant. Let's type a constant in here. And I have a value coming in. Let's say the value is 1. And I plug it in. And then we take this and copy it, Control-C, Control-V. And we plug this in, and let's say the value of this one is 2. So we ask ourselves, what is coming out of this value right here? Well, actually, it's two independent numbers. This is acting as X, and this is acting as Y. So appending is not multiplying or adding or doing anything like that. It's putting them in a list, one right after each other. So basically, if we type in constant and constant 2 vector, and we were to go 1 and 2, this is doing the exact same thing as what is happening above. If we do an example to show what's happening here, if I type in texture coordinate, texture coord, this is again the UV space for an object. If I type in a texture sampler, texture sample, and I multiply, hold down M and right click is the shortcut for that one. I click, my coordinates come in here, they go to UVs, they go out to base color, and I right click on my, left click on my texture sample. I'm just gonna come down to the texture and just type in brick wall. What you'll notice, again, I'm gonna change the little preview here in this corner to the cube, is that at first we have nothing hook up and everything is tiling as you should. One texture unit goes across because of the UVs. Now, I could connect this 2 vector up and you'll see it's now tiling one across and twice in the vertical. Because again, X is U, Y is V, UVs. Okay? So across and down. Now, if I plug in this, notice Nothing changed. And if we hover over the vector 2 node, you'll notice that you see how it says 1, 2? Two values, two separate values, ordered in a particular order are coming out. And that's the same that's happening on the text chord. Two values are coming out of here. And the same is happening on this append, two values. So append is a way for us to kind of create our own vectors in case we didn't have a particular vector 2. Say we had two vectors, and actually, here'd be another example. If we have our two vectors, I'll put this down here, and we add another constant value, and let's say we wanted to make this, let's say I put 0.5 in here, I want to turn this into a color for the base color. Well, I could just plug this in, and what are we going to get? Let's think before we do it. We're going to have just red and green. Well, I have 2, which is higher than 1 in the green. So let's put this to 0.5 because RGB values max out at 1. So if I wanted to add a blue, even though this node is white, we think about it as XYZ, RGB. So I can use an append node. I'm going to do append vector. And I'm going to append this now to this. So now they ask if two inputs come out, how many are coming out of here? And if I append 2 coming in and then another one, how many are coming out of this one? So if I hook this up, you'll notice the color changed because actually now instead of 2 values coming out, kind of like how it was here, 3 values are actually coming out that are ordered. So they're not getting combined, they're not getting multiplied, they're not getting added. They're adding to the vector. So append lets us increase the size of the vector to add channels so that they can be interpreted by things like colors or positions, and allows us a little more flexibility for how we set things up. So hopefully this gives you some more knowledge about how we could use this in the future, or if you've ever been confused about what append does, this gives you a better idea. Let's talk a little bit about masking and how that can be useful for us inside of Unreal. So I'm going to go into the content drawer, and I'm going to come to my core nodes here, and I'm just going to make a material. Feel free to make it wherever you've been saving. And I'm just going to right click, and I'm going to go up to material, and I'm going to name this M Masks 01. And I'm going to double click to open this up. And we're going to take a look at something called component masking. And component masking, so if I hold down the 3 on the keyboard and I left click, I'll get my constant 3 vector, and I'm going to plug this straight into base color. And I'm going to set it to, it's kind of like a yellowy orange color. So I have a little bit of blue, a little bit of green, a little bit of red. And what you'll notice is I have the full gamut, and I can see all my colors. So again, the white pin that we connected out to base color is actually 3 values. It's actually the red, the green, and the blue. So let's say I drag a pin off just red and connect it to base color. So what do I get? It's a single value. I'm only seeing this X value because again, XYZ equals RGB. So I'm getting 0.77, and I'm going off the Y, I'm getting 0.39, and then I got off the blue, I'm getting 0.3, so it's nearly black. But sometimes we can't have access to these, or we don't want to have access to these specific pins here. Sometimes we do math operations where we can't get access to them. So for example, if I do a world position node, you can see here that I have XYZ, but only Z, but I can't access just Y. And again, remembering that XYZ actually just means there's a position like XYZ here in colors. So if I do a thing called a component mask, so COM, and I click this down, you'll see by default, it's component masking down to the red and the green channel only. So if I come off this pin and then I go out, you'll notice it won't change too much, but basically it's removed that blue value. So again, if I come in my material and I make this more blue, it actually is removing all of the blue channel information, but letting the red and the green pass through. So it went from 3 pieces of information to 2 pieces of information coming out. And this can be useful. There's going to be times where it'll say, oh, down here in the information, you have a component mismatch. You have 3 pieces of information when we were looking for only 2. And Unreal won't let you do that because they're trying to make sure you don't make a mistake. where you're trying to feed something in and thinking you're going to get something out. So this can be really handy if, let's say I use the base color and I need to do something with this. I can actually, I'm going to Control C and Control V, the component mask. I can actually mask this down, and this mask is acting the same as this XY output. So I'm basically just dropping the Z component, because again, R is X, G is Y, and B is Z. So this can be really handy when we're working with certain pieces of data and we want to be able to limit what is coming in and out. A node we'll use a lot is called lerp, or linear interpolation. So let's take a look at what that does. So let's make a material. Again, I'm just making it inside this core nodes folder. Feel free to make it wherever you want. And I'm going to right click and go to material. And I'm going to name this m_lerp01. I'm going to click it to open it. And the very first thing we're going to do is we're going to right click and type in linear interpolate. And you'll see right here we have linear interpolate. And we'll get this kind of funny looking node here. And you'll notice it has an A, a B, and an alpha. And so we'll explain what that does here in a second. But let's left click and connect the output pin to the base color. And the very first thing we're going to notice is at default, A is assigned to the value 0. And B is assigned the value 1. But basically this node is saying is, let's blend between whatever's in A. So again, 0 is black. And let's blend with whatever's in B, pure white, by a percentage. So the alpha here will be a 0 to 1. So at 0.5, we're 50% in the middle of these two values. So if I want to see whatever is in A 100%, I need to set my alpha to 0. And again, we should see the output 0 at 100%, because this is saying at 0%, show me whatever's in the A channel. And at 100%, show me whatever's in B channel. So again, if I type in 1, it is the equivalent of 100% the B channel. So now I'm seeing 1 as white. To kind of drive this home, let's hold down the 3 key and right click or left click, and we'll get a constant 3 vector. And let's just put some blue in here. And let's Control C, Control V. Again, click on this and make it red. Hit OK. And now you'll see I have two colors. So let's plug blue into A and red into blue. And the alpha is at 1. So again, whenever this is at 1, it's 100% the B channel. If I set this to 0, it's 100% the A channel. And if I type in 0.5, it's a mix of the two. And you might be asking, well, why is this useful? Well, if we do things like time, which we can get into later, time with a sine, the sine wave of time into the alpha, you can actually see we can start to animate them, because this number is oscillating between -1 and 1 and going back and forth over time, and we're driving that to animated material. So without getting too much into this at this point, I just wanted to kind of show you how powerful this lerp can be and how this alpha value can let us kind of switch between, in real time, different values for, let's say, a grayscale texture or even the color of an object. So I think that'll wrap it up for now. I hope you guys have a better understanding of how linear interpolation /lerp works. A node that can be really handy in certain situations is the Fresnel node. Let's take a look at that right now. So let's open our content drawer and save wherever you want. I'm just going to be saving it in my core nodes folder here. And I'm going to right click, make a material, and I'm going to name this m_Fresnel. And it has a weird spelling. It looks like Fresnel. But once I'm inside of here, I'm going to basically open it up and I'm going to type in Fresnel is how you say this. It looks like Fresnel, but trust me, it's Fresnel. And once we add this, we're going to actually just take this output pin and we're going to go and connect it to the base color. And the first thing you're going to notice is now we have a dark color in the middle and it fades off, and at the edges of the material, it becomes bright white. And if I rotate around this object, you see that that white hue stays at the edges. It never kind of meets the middle. And what's happening here is based on the angle of us viewing this object to the angle as it fades away, we're able to see, we're getting this kind of reflection. And basically the idea was as light comes in at these extreme angles, it's more likely to bounce right into your eye. Instead of when it's straight ahead, you're just getting that direct light. And we can affect some of the components of this. So if I hold down 1 and I drag this into the exponent, which was defaulted to 5, and I set this back to 5, we'll have the same result. If I set this to say 50, you can see it's there. You might barely be able to see this little white line. So we can tighten it up that way. If I go the other way and I say I type in 3 or 2, you can see we're getting this kind of like glowing effect internally kind of creeping in on our object. And this can be really useful for things like foliage or soft things where at the edges it becomes a little bit lighter. And so that's just something for us to think about. Now, the base reflection in fraction, we can basically leave this as default or the normal. So if we have a normal map or other information, we can feed that in to help affect, because again, this is kind of looking at the reflection of the angle. So if we have these little normals, we want to kind of take that in to make it look a little bit more real. So hopefully you know now a little bit more about the Fresnel node and how it can be useful for us in our materials. Let's take a second to talk at a high level about something called transforming space. So let's go to our content browser and make a quick test material. I'm just gonna be in the core nodes here, but feel free to put it wherever you want. So I'm gonna right click, go to material. I'm gonna name this m_transform 01. And let's double click to open this up. And the first thing we're gonna do is let's put a texture sample in. Now with this texture sampler, again, I'm gonna come to the texture here. I'm gonna type in brick. And I'm gonna put the brick texture in and connect this to base color. And at this point, if I go to the cube, preview in the bottom corner here, which is just tucked in here, you'll see that the cube has an unwrap, and for each face, this texture sampler is being applied because they're all overlapping. But let's say that we went to world position, and let's say that I went out of this. We're going to do a multiply first, and we're going to put this to 0.01, and the reason why is because Unreal's in centimeters, and so if we don't do this, it'll tile terribly, and I'll show you what that looks like later. And because we're looking for UVs, we'll use a component mask. And I'm gonna take 3 positions, component mask down to 2, and you'll see that we have a cube stretched on the side, but these UVs are now in world position. I might be asking, well, what's that all mean? Looks like you just made the cube look worse. So let's apply this and then go put it in our scene and move it around and talk about what that is. So let me apply it. And then I'm going to bring this down here and just kind of leave it for a second. Let's just expand this. Let me drag it over just so you guys can see them at both at the same time. Okay. Now let's add a cube to our scene. So I'm going to come to this quick add to the project button. I'm going to go to shapes and cube. It's going to add a cube. I'm going to drag it over, lift it up. And I'm going to apply this material to this cube. So go to my content drawer, move this stuff around, and I'm going to click and drag it onto my cube. So left click on the material, drag it out, drop it on it. And you'll see this cube is in here now. Now, when I move it around, you're going to notice the texture is not moving with the object. The texture now is in world position, which can be really handy for us for doing things like, say, I Control V, and now I have a second object. They're perfectly aligned. The texture, if I pull it down or push it up, you can see it's almost like magic because the texture is projected in world space. It's based on the origin of the world, scaled out, again, based on this multiplier. At every meter now, we have a texture instead of every centimeter. And let's say that I wanted to change that again, because this is talking more so about transforming. So if I type in transform, you're going to notice a node here that says transform vector. And if, again, I'm going to full screen this, you're going to notice it's going to say underneath of it, from something to something. And by default, it says tangent space to world space. And when I have the node selected, over here you can see source and destination. So what does that all mean? Well, if I change my source to world space, which is what this is, so the input, so let's say we go in to world space. Right now it says world space to world space. First of all, it gets angry because it wants this, so let's move this over. Basically what it was looking for, because it was asking for world space, because we were masking it down from 3 down to 2, world space requires 3, X, Y, and Z. So we had to make sure to move our component mask till after, even though it should be fine. So this is world space to world space with that. If I apply this, everything should just work as it did before. Nothing has changed. Now, if I change this from world space to, say, tangent space, you'll notice, well, what happened? Now the cube looks like it did originally, because we went from world space and Unreal projected it back to tangent space. So if I move this out of the way, you can see now these cubes, they're adapting as they did before, but in tangent to the faces of the object, which can be really handy for us because sometimes we can get around some of those projection issues by doing this. And it's just a very high level understanding. World space is the position in the world context. So where do I live based on from 0, 0, 0? How far is that object from 0, 0, 0? That is world space. Object space is its own. So the middle of this object is 0, 0 and goes out from there. The other things we can look at is tangent space. That is, where are we in the position of the UV? So if I open up this chair, let's just say, let's just do this for demonstration purpose. And I open up, let's make this big. And let's show, let's take a look at the UVs. So UV 0. So tangent space is where am I on this UV coordinate? And again, upper top corner here is 0, 0. Bottom corner here is 1, 1, because again, X and Y. So that position is being converted from a world position, changed into a position that Unreal can look at in this context, which is very useful for us when we're trying to work on materials. The other thing we can look at with this transform node is, so we have a high level understanding of what tangent now is. Tangent is a fancy word for the UV space. Local is just the object. World is where does it live in the entire world. View and camera space are similar. It's basically from the camera into the screen. So this is going to get kind of trippy. But as you see, if I look around here, this is looking straight out of my camera and projecting it onto the screen space here. And if I go to camera space, you're going to notice it looks very similar. We don't need to get into the details specifically, but again, I'm going from world space into camera space and then getting the X and Y. So again, X is R, Y is G. It's the same thing. And it allows us to project in the camera like this. So if I save this, come in here, now you can see these textures are aligned, but as I move the camera space, they're being warped and distorted based on where the center of my camera and my screen are. They're getting different coordinate systems. So again, I just, at a high level, wanted you guys to be aware of the transform nodes and that things like this are possible. So if you have more questions, just feel free to ask them, and we'll see you in the next one. Sometimes we just want to have a texture or material that kind of moves left or right. Let's say that we had some kind of digital sign and we wanted that information to move to the left constantly over and over again. So let's look at what that would be inside a material editor. So inside the content drawer here, again, I've just made a node. Feel free to save this wherever you want, but I named mine m_panner01 if you wanted to follow along. And once we have that created, let's open it up and take a look what the panning node does. So to make this a little easier to see, the first thing I'm going to do is right click and make a texture sample node so that we can come over here to the details panel. Again, we want to make sure we have that node selected, and we're going to just add an image in. So I'm going to add in this AIcon green, but feel free to add any kind of image you want. And we're going to plug this into the base color. And at first, if I change my previous cube, we're going to notice that this isn't doing anything. It's not animating. It's not moving across. So let's look at the panner node. So let's right click, type in panner, and we're going to add this node. And what we're going to notice is that if we feed the output of the panner node into the UVs, at first, nothing is going to happen because this node is looking for a speed in either the X or the Y direction. So let's come in here to the speed and just type in 1. And what you'll notice is that our object is now panning in the left, right to left. Now, if we come onto this side, we'll notice it's the same. Now, if we type in a negative value, we can actually get the panning to go the other direction. And if I save this and I apply it to, say, my mesh, just for fun, we'll now have a texture that is panning across our object. And we could even do this, let's say, like on the monitor here, just to be a little fun. Now, it might be running a little odd or a little bit weird, and we can kind of clean that up. We could come in here, and where it is defaulting to time, we could always just come in, right-click, and use the time node, and use that as world time. And that'll kind of control it. And, or if we don't want to use that, what we can do is we can say, okay, what's the time, how fast we want this to spin? Maybe this is not moving at the rate we want, even though we have our speed here. But what we could do is take time, and we could multiply time. So multiply, and we can multiply this by like a small number, like by 0.1, put that into time. And you'll notice now, even though we didn't mess with the speed variable, we slow down how time is fed into this node. Again, this isn't really necessary to affect it, but I just wanted to make that be known. Now, let's say that we didn't want to have to write our values for speed into these little XY areas right here. Let's say that that's kind of hard to do, or we wanted to expose it later with some of the more advanced techniques. What we can do is we can right click and type in constant 2 vector, and we can actually just plug this straight into here. And why does that work? Well, because you can see that speed is looking for 2 components, an X and a Y. If we made just a constant value, just a single value, and plug it in, you'll notice that that works also. And you might be asking yourself, well, why is that possible? Well, what it's going to do is, if we plug this in, it's going to set whatever is in the value here to both X and Y. So if I do this and then I type in 4, you're going to notice that it starts to move on a diagonal, which is also something we could do here. So at a high level, I just wanted to kind of show you what would be possible with just this simple panner node so that we don't have to do too much complexity in terms of writing our own math to do this. So hopefully this can help you create some more advanced materials that need to kind of move across the scene. Cheers. Let's take a look at the time node and what that can do for us inside of the material editor. So wherever you want to, I just made a node called m_time_01. So feel free to place this wherever you want. And for right now, this is just a blank material. And we're going to talk a little bit about the time node. So if we right click and type in time, under our constants here, we should see time. And when we add it, you'll notice it's an input node. And let's just say we plugged it directly into base color. So what's happening? Well, a whole lot of nothing. Because we can't really see anything beyond the value of 0 to 1, this number is constantly increasing. So the whole time we're doing this. And how could we see that a little bit better? Because any value over 1 is just 1, right now this value could be 30, 40, 50, 60. We couldn't tell. We're going to use a node called frac, F-R-A-C. And what this stands for is the fractional component of whatever this number is. So you can think of it as we're counting up from 0 to 1, it'll goes 0.1, 0.2, 0.3, 0.4, all the way up till it gets to 0.9, then it'll be 2, right? Well, frac doesn't allow us to go to 2. It only allows us to return the fractional component. So let's show what that might look like. So if we connect time to frac and then out from there, what we're noticing now is that the object is starting at 0, then going 0.1, 0.2, 3, through up to 0.9, and then back to 0. That's why it goes back to black. And now we can kind of get this pulsing effect. And this could be something that's kind of useful for us if we wanted to kind of pulse up to a color, then reset, and then come right back down. Again, because we're only capturing between the 0 and 1 region, we've normalized our value coming out. And this can be really useful to do different math operations on. Another thing we could do is use the sine node. And there's 2 different sine nodes. Just be careful here. I'll just explain quickly. We have sine with an e at the end, and this is the trigonometric function for like a sine wave. Whereas sine is in like a stop sign sine is not the node we want. This will just kind of tell us, hey, are we at 0? Are we at 1? And kind of tell you that. But if we plug the frac node into the trig version of sine here and put that into base color, what you'll see is we actually get a pulsing. And what we're happening to notice is that the object is going to go, basically sine will always return a curve between 1 and -1. So if what you're noticing here is that this value seems to be black for twice the length of time, that's because, again, we can't show numbers less than 0. So once it goes black, it goes down to -1, backed up, and then to 1, negative, and we can see that curve happening. And again, this is possible through using this time node, which is constantly feeding in a value between 0 and 1, basically, to this sine function. Another way we can think about using time is we could get rid of these functions here, and we could use a texture sampler. So let's do a texture sampler first. Texture sample. And feel free to put in any time kind of texture you want. And again, we're going to come over, once we've clicked on the node, come over to the details panel, and you can add in any kind of texture you want. I'm going to use this AIcon green. It's a default object inside of Unreal. And if we plug them into the base color, we can see that our object is just kind of sitting here. It's not doing anything. It's not moving. Nothing fancy is happening. If I take the texture coordinate node, and again, a texture coordinate node is the information about the mesh that we are applying this to. It's 0 to 1 space, and we use that as its texture coordinate. You'll see nothing happens because by default, the UVs is looking at this node. But if we take this texture coordinate and we add to it, right, use an add node. So right click, type in add, and we add time to the UV coordinates. Let's think about what's going to happen. We have 2 values, x and y, coming out of here. We have a singular value here, but this value is going to be added, let's say it's 1, to both of them. So if this is 1, 1, it'll become 2, 2. If this is 1, 1 and time is 4, 4, now this will be 4, 4, etc., or 5, 5. So let's plug this in and see what happens. So what you're noticing is because we're adding it to both the x and the y at the same time, we're getting a motion on the diagonal. If we wanted to use time in a different way, we could be able to speed it up or slow it down. How we could do that is we can multiply. So just right click, multiply. Make sure you come up to this one, not the one that it defaults to now. Multiply this, and let's multiply time and then plug it in. And by 1, so whatever time is by 1, should just be the same thing. But if we put in 0.5 here, you'll notice we've cut the speed in half. We put 0.1 in. Now it's barely moving. So again, the time node can allow us to do panning. It can allow us to move things around in the screen. It can also help us pulse things forward and backwards. And we could also even go back to finish this out, and we could use that sine function again. And we could come out of here, use the sine function, and get some really wacky results. Again, because we've messed with the texture coordinates. If we do this before we mess with the texture coordinates, and we just do the sine of the information here, we can basically get a back and forth motion of our texture where it kind of moves in one direction and then ping pongs back. So let's just think about all the powerful ways that just having this little ability right here can give us. Again, we can add in that frac node that'll just return a more consistent 0 to 1 range. And we can better control the rate at which what's happening here, because we know we're always getting basically a 0 to 1 value feeding into here at a certain rate of time that it's moving at. So hopefully this gives you a good overview of the time node, how we can use it to make values go up and down over time. Say we wanted to make a light get brighter and darker, or how we could use it to edit the UVs of a mesh for a material to then pan them or move them around. So hopefully this was useful, and I'll see you guys in the next one. Let's talk about vertex painting, what it is, how we use it, and the limitations of vertex painting when it comes to nanite. So the very first thing we're going to do is we're going to make a material. Instead of the content drawer here in the core nodes, I just made a folder called, or a material I should say, called m_vertex painting 01. If we open this up, what we'll notice is we have no material yet. And the thing we want to start looking for here with vertex painting is the vertex painting node. So if we right click and type in vertex color, vertex color is what we're looking for. And what that means is that this preview sphere, let's say for example, is actually made out of a lot of tiny vertices. And each one of those vertices, when the mesh is saved, holds a position, but it also, under the hood, holds a particular color. And we're able to come along and assign a specific color to those points. So let's just add in, let's right click and type in LERP for linear interpolate. And we're going to use the vertex color to drive which material is seen. So again, let's do it with the red channel. So we have basically 3 and 4, if we think about the alpha as well. We have 4 grayscale 0 to 1 maps, and the alpha is looking for grayscale data. So as long as we are thinking about what the red channel is seeing, we can show a particular material or not. And let's just hold down the 3 key and do it twice and make 2 constant 3 vectors. I'm going to plug these both into the LERP. And let's set one to red and one to blue. Okay, so as of right now, if we connect the output of our LERP to the base color, we now have a simple setup. What we have is these 2 colors based on what value is in the red channel. Again, 0 to 1 information. If it's 0, it'll be red. And if it's 1, it'll be blue. And if it's anything in between, it will be a blend of these 2 colors. So let's just save this and take a look at what this looks like on a mesh. So I'm going to close this, and I'm just going to create a sphere. I'm going to come up to the quick add to project. I'm going to go to shapes and sphere. And once I have this created, I'm going to drag it up here, and let's apply, I'm going to left click and drag mine onto my sphere. So again, at this point, nothing very special has happened. If we take a look at our material, anything that is 1 is going to be blue. So what does that tell us? That tells us that this object is defaulting to a color in the red channel of 1. So how do we access where to paint? Well, inside of Unreal Engine 5, if we come up to the upper left-hand corner here where it says selection mode, if we click on this, we have a few different options, and one of them is called Mesh Paint. When we click on Mesh Paint, we're going to notice a few things happen. So let's click on it. The first thing that's going to happen is we're going to get this new panel on the side. It might be somewhere else for you, but typically it's over to the left. And we have 3 different options here. By default, we want this to be set to color. And you'll notice that we have a couple different tools in here. We have painting, swapping, and filling and whatnot. So if I have this object selected, let's go to click on paint. And let me just close the material down here for a second. I'm going to save it. And what you're going to notice is that it's currently painting this color, pure white, and we're also painting into all 3 channels. If I were to click this little swap button here, it'll swap it and be my primary color would be black. And right now, if we imagine that this whole thing, all the vertex colors are white because that's why we're seeing the blue. If I fill this with black, notice the whole object turned red. Now, if I come back here and I swap it back again, but this time I use the paint tool, and I just left click and drag around. As I left click, drag around, you're noticing a few things are happening. 1, if I stay in an area long enough, it becomes solid blue. 2, in some areas, I'm kind of getting this light purpley look. And if I keep painting it out, you'll notice is that because the vertex painting is resolution is dependent on the number of vertices. If you notice very carefully as I move around, these little green dots appear. each one of those green dots represents a vertice. And so we can only paint a particular point. So if we only have, let's say, a bit of information here, but not much here, we're actually going to interpolate or find the average of the two colors, which kind of gives us this purpley edge between the two vertex colors, which can be kind of helpful. It gives us kind of this softening look. The other thing we need to be aware of is that we can come in and we could turn off the other channels. So we could just paint into the red channel, or if I came down to my channels here and I was only painting into the green channel, you notice I can't really do anything because our material wasn't set up to support that. If we wanted to be able to paint into multiple channels or use them for different effects, we could also come in and pull off this channel and use its data to drive different textures. The last thing I want to tell you guys really at a high level, a basic announcement of what vertex painting is and how we can use it, we should talk about how it is not supported currently in Unreal by the Nanite system. Now, this might come along in the future, but let me close this out and go to selection. And let's just take this sphere here. And what you'll notice is that right now I am seeing the vertex color. Well, this mesh is not set up to support Nanite. And Nanite is the special set of tools within Unreal that allow us to basically have infinite geometry. And through that process, we can take a mesh, take all of its vertices, and decide how many triangles and vertices we should see at a given time on the screen to make sure that we don't make something too high poly, but also if we zoom away, we're kind of like lotting it automatically, but at the whole screen level. And by doing that, we're invalidating the position of the vertices, so therefore we don't have a good way, as of right now, to make sure that these colors stay where we want. And we can prove this by just taking the actual mesh. So this is a sphere mesh that comes inside of Unreal Engine. If we browse to that selected asset or open up its content browser location, if I open up this mesh, which you'll notice is in the search panel, if I search for Nanite and I enable Nanite support on this mesh, the first thing that happens after I come down here and apply changes is it will need to recompile the shaders. But now you'll notice all the painting I did is now gone. So I just want to make sure you're aware of that if you're messing with vertex painting inside of Unreal Engine. To pull off a similar effect, you would most likely have to use a mask, a white to black value, that you could paint inside of another program to make sure that we can achieve the same look. So again, if you don't need Nanite support, you should be able to use your vertex painting just fine. But if you are in a crazy expensive project or you're noticing vertex painting isn't showing up, that could be why. So hopefully that makes a little sense and gives you guys some insight into vertex painting. Again, we can use it to blend different textures or colors together, and this can be a very helpful tool in your toolbox inside the material editor.